Hello everyone, my name is Ebito Tom and I'm a student at British Abel College, Umalquin. Today I will be presenting my project called NeuroSentinel, an AI-powered system that detects cyber threats, stops them automatically and keeps your data safe in the cloud. So, why did I build this? Today, cyber attacks are increasing every single day. Hackers use ransomware, malware, and other dangerous tools to attack organizations. The problem is most security systems only know how to block attackers they have seen before. If a new type of attack comes along, they simply cannot stop it. And now that so many businesses are using cloud storage, and the risk is even bigger, that's a problem that we need to solve. What we really need is a smart system that doesn't wait for human to react. It should be detect the threat, respond to it, and protect the data all on its own in a real time. That is exactly what NeuroSentinel is built for. To build this system, I have researched the five main areas. The first one, how AI and machine learning can detect threats. The second one, how to monitor system behaviors to stop unusual activity. Third one, how to back up data securely in the cloud. The fourth one, how to protect data using encryptions. And fifth one, how a real-time intrusion detect the system works. Five these areas together gave me the foundation for the NeuroSentinel. Before building anything, I have studied the existing research. Uroj and team in 2022 showed up that the machine learning can detect ransomware, but the system could not do anything after detecting it. No automatic response. Herrera and Sylvia at the team in 2023 built a system that classify malware were accurate, but again no containment or no recovery. Kumar and Sharma in 2003 use AI to detect threats. It would be in cloud system, but it didn't work well with the endpoint device. So all three studies were good at finding threats, but none of them could stop recovery from those automatically. This showed me the clear gaps in the current research. The first system focused only in the detections. They find the threats but do not act on it. The second one, the systems are built separately. The detections is the one tool, encryption is another, and backup is another, but nothing is connected. The third one, there is no fully automatic response, no single system that detects, contains backups and alerts altogether. That's the gap NeuroSentinel fills up. The big insight from my research in this, we we don't need to just another detection tool. We need one complete system that handles everything from spotting the threats to locking down the data to saving it safely to telling the admin what happened. That's the opportunity what I built. So I set three clear objectives for this project. First one, using machine learning to detect threats based on behavior. The second one, automated isolate and contain the threats without human help. The third one, securely backup and the data to an encryption cloud storage. What does this project contribute? A complete connected security system, not separate tools, and automated response that works without anyone pressing a button, and smart detection that catch a new threats, not just known ones. The overall goal is simple: building an AI-powered system that can detect stress in a real time, stop them automatically, and recover the data safely. More specifically, the system needs to do four things. The first one, detect the threats using behavior analyzations. Second one, encrypt important data the moment a threat found. Third one, store that encrypted data safely in the cloud. And the fourth one, send a real-time alerts and logs to the administrator. Why did I choose this topic? Because cyber attacks are growing faster, because the current systems are not good enough, because AI have proven it can be make real difference in security, and because these solutions have real value in the place like hospital, banks, and government office where the data can protect in criticals. Now let me explain how NeuroSentinel works. The system constantly watches three things: file activity, process behavior, and the network traffic. If anything looks suspicious, it flags it and immediately it doesn't wait, it monitors 24 into 7. Here is a step by step how flow system works. The first one, the system collects the data about what's happening on the device. Second one, the AI analyzes this data and checks for anomalies. The third step, if a threat is confirmed, the encryption module logs the critical files using AES 256. Step 4, those encryption files are uploaded to cloud backup. Step 5, the dashboard shows the admin everything that happens in the real time. The core The system has five modules working together: threat detection, automated encryption, cloud backup, alerting, and logging, and the dashboard. Each one does its job, and together they for one complete security solutions. Let me go for a little deeper into each module. The threat detection modules use machine learning. It learns what normal behavior looks like, and when something unusually happens, it raises the alarms. It can even catch branches new threats it have never seen before. Encryption module immediately when the threat is detected, and it's used AES 256 encryption, one of the strongest encryption standard available to lock the files so no one can access them without the keys. Cloud backup module then takes those files into the location of the cloud, and this is ensuring that when even if a local system is completely destroyed, the data can be still be recovered. Methodology. For the research methodology, I use the design science research approach, which means I'm focused on actual building something useful, not just theorizing. I analyze the dataset that include both normal system behavior and attack scenarios. I use supervised learning for threats we already know and anomaly detection for new unknown threats. To measure how well the system works, I use precise and Rucker and F1 score, which are the standard ways to evaluate the security system. Based on this approach, I expect four key results: better detection of ransomware and malware, faster containment, the system response before damage spreads, the less data loss, backups because backups happens automatically, and faster recovery so organization can get back to work quickly. The contribution of this project bringing the is bringing everything together in one place. Instead of using five different tools that doesn't talk each other, NeuroSentinel gives you one connected system that detects response, backups, and alerts automatically. This has practical value in health center, finance, and governments right now. I also want to be honest about the current limitation. NeuroSentinel is still a conceptual system. It has not been deployed in real world environment yet. The AI model depends on the quality training data, and scalability needs more work. These are areas for future research. But the alerting and dashboard system is a key strength. When a threat is detected, administration get instant notification. The system records a full log of what happened, what the threat was, what the files were affected, what the actions were taken, and the dashboard shows all of this in one central place, make it easy to monitor and manage. NeuroSentinel moves cybersecurity from reactive to proactive instead of cleaning up after an attack. It stops attacks before it can do serious damage. It threats early using AI behavior analyzations. It responds instantly with encryptions and cloud backup, and it gives organizations the tool to recover quickly and confidently. It's built for a place where security can fail, hospitals, banks, and government systems, and it makes those environments significantly safer. I would like to thankful the faculties at British Library College, especially my guide Jency Varghese and Angela Mary Paul for their supports and guidance throughout this project. Thank you so much for watching. I hope NeuroCentinel show you how AI can make our digital world safer, and I am happy to answer any questions. Thank you.